Here we have an example of when we have multiple non-perpendicular vectors. So our problem reads, a student folds his lab paper into a paper airplane. This is not advised. And then he throws it. The airplane travels 2 meters at 41 degrees. Then the wind changes and the airplane flies an additional 6 meters at 23 degrees. What is the total displacement of the airplane? Okay, so I'm going to start by drawing two different triangles. I'm going to start with a 2 meter at 41 degrees. And then 6 meters at 23 degrees. Okay. So for each of these, I'm going to find the x and y component. Then I'm going to add my x's, add my y's, and draw a third combined triangle. So let's look over here at this triangle first. Now, anytime I'm trying to find my components, that's when I'm going to use my trig functions. I know that for x, I'm going to use cosine. For y, I'm going to use sine. So cosine of 41 degrees equals x over 2 meters. Sine of 41 degrees equals y over 2 meters. And I can rearrange by multiplying both sides by 2 to get my variables by themselves. And so I should have 1.5 meters in the x direction and 1.3 meters in the y direction. I'm going to do the exact same thing over here with my second triangle. So cosine of 23 degrees equals x over 6 meters. Sine of 23 degrees equals y over 6 meters. And so this should result in 5.5 meters in the x direction and 2.3 meters in the y direction. Now I'm going to combine my x's. So here I have 1.5 plus 5.5 should give me 7 meters. Going to do the same thing for the y's. So 1.3 plus 2.3 should equal 3.6 meters. And I need to find C. I need to find the total combined displacement. So I have my two sides of my triangle. I'm going to use the Pythagorean theorem to find the third. A squared plus b squared equals c squared. So that would be 3.6 squared plus 7 squared equals c squared. C squared equals 61.96. So if I take the square root of that, that's going to give me approximately 7.9 meters. And now I can find the angle. I can solve for theta. So if I look here, let's do cosine. You can really pick any of your trig functions at this point because you know all three sides of your triangle. So cosine of theta is equal to 7 meters over 7.9 meters. Now in order to get theta by itself, I need to do the inverse, the opposite of cosine to both sides. So theta equals the inverse of cosine, 7 meters over 7.9 meters. So theta is approximately 28 degrees. So my final answer should be the total displacement of the airplane was 7.9 meters at 28 degrees.